So hello everyone, welcome back to the channel. So in this video, we are going to see the second problem of weekly contest 309. That is number of ways to reach a position after exactly k steps. So I hope that you have understood the problem statement. But in case if you're in doubt, we can understand the problem using the example. So what we have given in the problem is we have given three variables. The first one is start position, the second is the end position, and the value of k. So what we have to do is we have to reach from start position to the end position using exactly k number of steps. So for the first example, you can see that we have to go from the position 1 to position 2, and in the explanation part you can see that uh, we will get exactly three different ways to reach to the end position using exactly k steps. So this is what the problem is asking. So one thing to notice in the problem is that uh, it is asking about the number of ways, not the actual path that you will have to take to reach to the end position. So since we have to count the number of ways to do a particular task, you may get the intuition like what type of problem it can be. So it lies in the domain of DP, that is dynamic programming. So we will be solving this problem using dynamic programming. So how will we going to solve? Let's see the explanation part in the whiteboard. So suppose we have two variable, that is d and k. So d signifies that the distance between the start position and end position. So in this example, I have taken d as 2. This means that the distance between the start and the ending position is 2. So the start and ending position can be any. Like if the start position is 1, then the ending position will be 3. If the starting position will be 5, then the ending position will be 7. So I have taken just the distance between these two positions and the variable k, So what we can do with these two variable t and k, we are uh, in the question it is written that we can just move one step forward or backward from the position I. So when we have the distance as 2 and with the value of k as 3, we have two possible choices. Either we can move back or either we can move forward. So if we moved in the way such that the distance between the starting and the ending position will decrease, you can see that if our d is 2, if we decrease by one step, then it will be equal to 1, and the value of k will reduce by 1. So after every operation, the value of k will decrease. So if we are moving towards, like if we are decreasing the distance between the position, then you can see that we will get a less number than the current number d if the distance between the starting and the ending position is increasing. Initially they have the distance 2, when they have the distance 3, that means that we have moved forward, like we have moved far away from the ending position, and then the distance between them has increased. So these are the two possible choices that we will have. So after every step, you can see that we will again have two possible choices, to either to minimize the distance or to maximize the distance. And at every step you can see that the value of k is decreasing. So you can see that this 2 comma 1, that is whenever d is 2 and the value of k is 1, you can see that this subtree is repeating in this recursion tree. So this is how we get the idea to apply the dynamic programming, since we will get the overlapping sub problems. So this is the main part, that we will memorize this solution and we will use that to generate the problem of our solution. So let's try to write the solution of recursive TP. So here we are in our code editor. So let's try to implement the approach. The first thing what we'll be doing is we will create a DP array. So it will be a 2D matrix. So, and the number of rows will be equal to 1000 and the number of columns will be equal to 1001. Why? Because you can see that if we take the absolute difference between the starting and the ending position, it will be limited to 999. And the number of column, you can see that it is ranging from 1 to 1000 only, so it will suffice the condition. And the other thing that will be do is we will create a mod variable that will be equal to 1e9 plus 7. Once we have done this, we'll move into the function number of ways, and we will initialize our dp to -1. For that, we will we will use the memset function. After this, we will create a function dfs that will take the first argument as absolute difference between the starting and the ending position. That is the distance between these two position. And the second uh, then the second argument will be equal to k. So once we have done this, we can just return it. So it will return our answer. So now it's time to implement this function. So we will write int dfs, and we will write the variable d and k here. After that, we just have to write the recursive relation. So there are only two possible ways: either the d will be decreased or it will be increased. So we'll create two variable int a. So if our distance is decreasing, then we can write the function again and we'll pass the variable value t minus 1. And after every operation, the value of k will decrease, so k minus 1. And we will do the similar thing, that is, we will create another variable p, and we will uh, in this function we will increase the distance between the starting and the ending position, so it will compute this. So once we have done the computation, we can write the dp d and k equal to the summation of these two variables. So to uh, to protect it from overflow, we will take the modulo from the mod variable, and we are done. And after every recursive call, we just have to return the dp, the value of dp d and k. So we have done this. So now it's time to write the base case. So what will be the base case? So you can see that we have to use exactly key operation to reach from starting to ending position. So at every step you can see that the value of k is decreasing. So if our value of k become equal to 0, then we just have to check either the value of d is equal to 0 or not. So what's d equal to 0 will signify? So it will signify that the starting and the ending position is coinciding. So in that case we just have to return 2. So writing d equal to 0 will suffice that. So this will be the base case. And the other thing is, if the value of dp d and k is already computed, we don't have to recompute it. So we can then just simply write return dp d and k. So this will do that. And one thing that is we are forgetting is, if the value of t is greater than k. So if the value of d is greater than k, what does that mean? Even if you apply k operation to decrease the value of d, it will be greater than the 0 at the end, because the value of d is greater than k. So in that case, we cannot reach to the ending position from the starting position. So because of that, we have to return 0. So I think that this approach will work. So let's try to submit this code. So as you can see that this approach is accepted. So this is one of the way to solve this problem. So I hope that this approach is clear to you. So for any doubt or any query, you can just comment it down. I will try to resolve it. So thanks guys. That is it for this video. So let's meet in the new video with a different problem. Till then, happy leet coding.